Okay, good morning, everyone. So today I'm going to talk about concept modeling. So this part will enhance more knowledge about how to categorize your problem in 1D, 2D, 3D, and how to be proceed for the analysis. Fine. So before talking about this thing, I would like to explain about 1D, 2D, and 3D. Look at here. So 1D analysis, one dimensional analysis, or else we can write 1D, 2D, and 3D analysis. Fine. So even we have the 0D analysis also, but I'm not included that one. That I'll tell you that 0D analysis in a meshing point of view. So mostly 1D analysis, it covers bars, frames, truss, and pipe related elements, pipe related problems. Okay. Problems covers means that where your uh, cross section is uniform along only one direction, we can say that problem is belongs to 1D analysis. 2D analysis is means that your cross section is varying along the two different axes, either it will be an xy or y or zx. So such a kind of problems we can consider as 2D. Let me say plane stress problem, plane stress, plane strain, and axis symmetric problem. Axis symmetric problems. And 3D, your way cross section is varying along all the three sides, as well as it show the big differences. So we can't convert any other possibilities into 2D or 1D. That is what this 3D. So almost all real problems we can consider it. So how the 1D problem will be look like, that I'll tell you. Look at here. So mostly 1D problems will be considered as a uniform cross section in the bars. So if you consider this bar, so the cross section is common on once you're cutting on here, once you're cutting on here, and once you're cutting on here, once you're cutting on here. So it is a square type of cross section, but this square type of cross section is common to throughout the entire length. So that is what we can consider this problem as to be an 1D. So this complete structure, you can take it as a line. That's it, line body. So you can patch the cross section over here. Similarly, for the frames you might be seeing. For a simple example, you can take a photo frame. So photo frame is just for understanding. I'm just telling an example, but such a kind of application also would falls under this. Then truss. So truss problem you could see a lot of places like gardening, that walkable areas, or else your steps. I mean steps side supports, or else electronic cell phone towers, or electric power towers. So you can consider. So means that over there it will be comes like this, the linkages. So since it is a ground level, so here it is a fixed one, here also it is fixed one. So you are making a linkages. So linkages, you are making a linkages. So even you could see these things in railway domes also. Railway domes top side, this kind of truss will be playing. So here they'll be patching the uniform cross section. Here they'll be patching the uniform cross section. Here maybe if it is C type, or if it is circular type, if it is L type, they'll be patching the entire length of the beam. So what is the necessity means that if you do this thing in a 3D, the machine complexity will be so complicated. In order to avoid that, they converted this 3D problem into 1D way. So once you are applying the loads, so how this linkages will receive uh, what is it, stress, strain, shear force, and bending moment diagrams, all the things. Fine. So pipe related problems, even the pipe also, if it is having a uniform cross section, you can apply your 1D body from the 3D body. So these are all one aspect. So second case, that is 2D problem. So for 2D problem, when you can consider, no, your cross section is varying along the two axes. So here I mentioned the plane stress problem where your stress can be not equal to zero along the two axes and where the stress is zero along the third direction. For example, I can say that sigma x, sigma y equal to not equal to zero and sigma z which is equal to zero. What does it mean? Means I'll show you. Look at here. Take one convergent nozzle or a divergent nozzle, whatever. So if you cut the middle, what will happen? In the top you, so it seems to be like tapered, right? It seems to be like tapered section. Tapered section. So if you consider this is along the x and this is along the y, so whatever the forces you are applying through the externally, so those will be showing the reaction along the x and y. That is why stress along the x direction and stress along the y direction is not equal to zero, and stress along the z direction is equal to zero. Means that the third direction it will not consider any forces or any stresses. Even though if you consider the stress, that stress is negligible effect, very negligible, very negligible. Similarly for the plane strain problem also, so strain along the x and y direction is not equal to zero and strain along the z direction is zero. So axisymmetric problem, so this considered to be an axisymmetric problem and uh, same like a plane stress and plane strain. So now how do we do this 1D and 2D 3D in our Ansys software? Come to the software part. First of all, you can create a 1D body with the help of line from the points, line from the edge sketches, and line from the edges. So this 3D curve also you can do, but this is a flexible one, but others are not a flexible one. So thus first four tools will help you to convert 3D to 1D. Fine. I will tell you how to create such a kind of 1D bodies with the help of these four commands. See, you are going to create a line body with the help of points. So we don't have a points. So you can create a points from the create menu bar. So here we have a point. So there are plenty of ways as I discussed in the previous video, right? So here either you can access from the coordinate file or you can create from the manual input. For example, let me go with the manual input. So 0, 0, 0. So keep your axis anyway. So it just simply generated. Look at here. There is one dot came, right? This is the origin 0, 0, 0. Add one more point. So that is, here's a shortcut, pinch. So manual point. So 1 meter, 0, 0. And I'm generating. Look at here. It is closure nearly. So click the look at view. So look at the first point and look at the second point. So you just scroll out for zooming out. So third point I'm going to create. So look at here. So manual point. So 1 comma, and I would like to give 2.5 comma or else 0.5. Let me take 0.5 in generate. Similarly, fourth point. For every time you need to click the generate. So 0 comma 0.5 comma 0. So we got a 4 points, right? So what we could see the first option is line body you are going to create with the help of points. So I have a point now. You can create a line body. So how? Click this line. So look at here. It is adding the material. Means that it is going to extrude it. Extrude in the sense not completely. It's a line. It will be going to extrude it. So as for the understanding, look at here, we don't have parts and bodies, right? So what you do is you can click the point segments. So point number one, and use control to select multiple. Again, one, two, again one, two, again one, two. Now we have a line, right? But it is not like a sketching. Since it is a body, you are going to patch a cross section. So you need to apply here and add material. So once you click the add material, look at here. There is one part and one body it came. Means that here it is a part now. For linkages or any bars, any beams or any truss or frames, you can consider it as a line body. Okay, 1D body. But once you pinch this line body, it doesn't have any cross section. It doesn't have any cross section. We need to patch the cross section. Even once you click the arrow mark button, it doesn't have any cross section. For accessing the cross section, go to the same concept. In the last, we have one section called cross section. So we have a lot of things from the rectangular, circular tube, channel section, I section, Z section. Like there's a lot of things is there. And also, if you want to flexibly create a cross section, so you can use this one. First, let me talk about this thing. When I'm coming to the last segment, I will explain you about the user defined and user integrated. So click the rectangular cross section. So now, so rectangular cross section segment is created in the tree. So by default dimension 0.01 meter and 0.01 meter is available, right? So rectangular cross section. So now you click here and that rectangular cross section is appeared on this box so that it will be works. Okay, look at it here. Clear. So now how do we see this thing? Still it is an arrow mark, I mean yellow color tick mark. So what is the problem? And the problem is actually your unaligned edges. I mean, what to say? This arrow mark indication. Look at here. So if the x-axis along, I mean, this y-axis falls on this side, then it will become like proper. So now it is not proper. So you need to flexibly change these things. So look at here. Right click, align. So look at this positive y direction. Set this thing to positive y direction. For y direction, you can pick zx. Apply. So it is not valid. So what you do is vector based or else selection based, but xy. Apply. Look at here now. Now it has got a green tick mark. Fine. Now still we patched the cross section, but we couldn't able to see that one. But how do we see now? Go to the views, click the cross section solid so that we could see the cross section solid. So this connection is nothing but a kind of fixed connection. You don't want to give any separate welded joints or like that. Since we made this, both the things are merged, so we can't in the sense there is no requirement to make this one in a separate thing. Maybe if you want to make it flexible, so you can create some flexible things so that these things would be rectified. Okay, maybe if you want to patch the circular cross section also, that is welcome. For example, in the cross section, so I would like to add one more cross section, that is circular cross section. So 0.01 meter, and come to line body. I'm changing the circular cross section. Look at here, see the circular cross section. Suppose if you change the cross section diameter is 0.1, look at here now how it is look like. It is little bigger. Suppose for the rectangular cross section, if you want to set 0.05, maybe if it is rectangular cross section, look at here. Look at here. Look at here. How it is. Hope so you understood. Fine. This is what the lines from the points. Now lines from the sketches. So for that, I'm going to take a new window. So go to the sketching and yeah, you can take like this. Okay, go to the modeling part. So look at here, lines from the sketches. So you can click. So I just drawn through the sketching. So sketching made. So base, it's available. So you can pinch the complete sketching and add metal. You can use add metal or add frozen, which one is comfortable, you can set it. It's not an issue. So generate it. Look at here and look at the cross section. It doesn't have any cross section. So if you would like to patch the cross section, what you do, go to the concept and use circular type. So maybe I can fix 0.505 and I'm going to set circular and see cross section solid. Look at here, it is patched. It is patched actually. Maybe if you change this dimension to 0.1 and look at here, now it is little bigger. Maybe if you set the cross sections to be 1 meter, look at here, now it is bigger. Fine. This is for the line body you are creating from the sketching tool, not a point tool. Okay. Now what next is simple. So you are going to create line body from the edges. Edges, no? I'll tell you how. So go to the new one. Either you are importing a body from the external geometry, or else you are creating the primitives from that body. We are going to do an line body. Means that, see, now I'm going to fix the frame for this all the six. Sorry, how many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 edges are available. So for the 9 edges, I'm going to patch the frames. So look at here, I'm going to patch the frames. So I'm going to take an L-type cross section for this and generate it. So now here under the sketching, sorry, not sketching. So come to this solid part. You can't able to directly patch the L-type cross section since I'm not yet enabled the line bodies. So go to the concept, lines from the edges. So select this edge alone. So select the faces also. If you would like, you can select the complete edges. You can select the complete edges. All the 8 edges you selected, apply. So faces not yet selected and generate it. Look at here. So look at here how it came. So now I want to patch the cross section for these edges. So line body, select the L type of cross section and see views cross section solid. Look at here. Since it is yellow color tick mark, so it is a problem. So how do we rectify the problem? So how do you invert this one? Because of not inverting, that is why the problem comes. So what you do is, so what you created on the line body, you just edit the section and you pinch only one edge first of all, apply and generate it. So look at here, it's created, right? So what you do is you just right click and select the unaligned line edges. So it is toward the Z direction. Change this thing to other direction. For example, XY direction. So pinch the XY direction, invert it, apply. Look at here. Now it's turned into a proper thing. Correct? Look at here. It is sticky one. Don't panic about this thing. Why it is clearance and all. Don't think panic. So it is patched. So similarly, you can pinch one more stuff over here. Right click, edit the selection. Not only this edge. So select this edge also. Apply, generate. Now look at here how it's created. So other two sides it is not perfect. So we need to adjust it. So how do you adjust it? Since it is three things are common, so you can't able to do it. So what you do is one by one you can do it. One by one you can do it. Edit the selection, change it to XY towards this direction, apply. Apply. Look at here. Right click, narrow the selection, Maybe only problem is, just a moment. Why is it? Apply. Look at here. Make it reverse. Apply. So which direction it is? First of all, look at here. So XZ you're supposed to select it. Sorry, ZX you're supposed to select it. Apply. Towards opposite direction. Apply. It came right. Generate. Similarly, you create a line from the edges on the other side. So this side, now you select. Apply. So you can attach these two faces. If you attach this, then other edges also will be considered. So don't give the faces. Generate. So now it came normal wish. So similarly on our next one. So lines from the edges. You can pinch this. Generate. It is a selection. Only this edge. Apply. And uncheck the faces. Generate. Now this is what the line body, right? Okay, in order to do separate things, so what you do is edit the section, apply, add this thing, so it came here. So the cross section, L type of cross section you can patch. So on here, you just edit it along X, not X plane, laser X plane. Apply. So now you just edit it. Actually, we need to do as per our own wish. Actually, generate. Since it is not showing that unaligned, because it's this case it is properly aligned because we set it the direction is different. Now these two things is not a clear. So what you do is better you can take an individual edge and do it. The rest of the thing you just explore, self-explore it, so that you can get a good practice. Okay, you can delete it. Look at here. So once again I'm pinching this one, creating line from the edges. I'm generating. Okay, add frozen, generate. So cross section, L type. So right click, unalign. So how it's supposed to come now along the negative x-axis. Apply. Look at here. Now it patched right. Once you hide this solid, you could see the rest of the frames. Look at here. Clear. So right click, show all bodies. So still only one thing I am going to do. So pinch this concept from the lines from the edges. Apply. Add a frozen. Generate. Patch the cross section. So right click, show the unaligned. So which direction you are going to flip it? So towards the Z axis you are going to flip. So positive x, so negative x. Then only it will be flipped. So look at here. Now it's flipped. So this is how you can create a frames. Okay. Only this makes some complexity since both the edges are merged. You are not given here as add frozen. So that now look at here. So 1, 2, 3, 4. Here it is first body, here it is second body, here it is third body, Here it is fourth body, but it doesn't have any cross section. I set it the cross section. Now look at here. Right click, unalign. So positive z axis. So XY plane. Apply. What you do was you can click this one and delete it. One more time you can create that one same lines from the edges. You can pick, apply, generate. Now it came. Sorry. And here change add frozen and create it. Now the last one. I'll type of cross section. Now it created. So since the arrow mark is indicating toward this direction, that's where it came. So now anyhow you have a proper tick mark, so it won't be a problem. So you can pinch this body and right click, hide the body, so that the frames is coming properly. Okay. I hope so you cleared about the third 1D body creation way. Fine. So next is I'm going to create a new one. 3D curve. 3D curve, either you can create from the point selection as you created a previous point, or else from the coordinate file. Why the coordinate file importation? No, suppose if you have a 1 lakh points, so will you type everything? No, it is not possible. For that, you need to work it on here. Okay, so for that, what you do is right click, create one text document. So type coordinate file. Okay, enter it and type hash group tab hash point tab hash x tab hash y tab hash z. So group, that is one, so only one group. I'm going to add this much points. So points 1, just a moment, 0 comma 0 comma 0, group 1, point 2, 1 comma 0 comma 0, same group, point 3, 1 comma 1 comma 0, point 4, point 4, 1 comma, or else 1 comma 0.5. You can type 0.5 comma 0 and 0 point, sorry, 1 comma 0, first point, first group of the point, 1 comma 1.5 tab 0. So then another point 6, 0 comma 1.5 comma 0. I'm saving this one. So like that only you need to save it. So what you do was on here, so here in this coordinate file, click the triple dot, click desktop. I saved the file in terms of coordinate file, click that one, so it is replicated here. Look at here. So this is through this fashion only you need to create it. So you know you can set the planes and you can set the operations, whether add material or add frozen and generate it. So one body, one part is created, but it doesn't have any cross section. You can set the cross section. Maybe for the link, you can set no for a kind of pipe. So you can use a circular tube pipe and click on here, select the circular tube so that it will be replicated. Click the view cross section solid. So look at here. Look at here. This is how this will be creating. Okay. So what next is splitting the edges. You can split the edges up to here or certain level. You can split, click this one, apply. So 0.5, no, what is the enter length? 50%, it is discretized. It will be discretized. Look at here, it is discretized. So edge number one, edge number two. Maybe if you set to 0.75% and generate, so it is one. Look at here, it is one, and other 20% is two. Okay. So now what you do is you can change the fractional to split by delta. Delta, no, the difference level. So 0.25 difference level it will take everywhere. Okay. So I'm just simply generating. Look at here. So this is my one, first one, 2, 3, 4, 5, 6, 7. Likewise, for the enter length, 0.25 meter, it will be discretized. So maybe if you want to set the number of divisions, so you can set 10 divisions. I want to set it, but 0.5. So generate it. So 10 divisions accordingly it will create it. Look at here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The rest of things, it is a larger distance. If the point 5 is extended up to here, so it will be discretized accordingly. If we give 11, so accordingly 11 things it will be creating it. Okay, so likewise you can split your edges. The purpose of splitting the edges is very, very important for CFD problems and not for structural problems. Fine. Maybe for the structural problem, if you can use this area as being a point load would be applying. Okay. So for simply supported beam or point load applying on the mid location or connecting location, you can use this options. So come to the next one, surfaces. So now we are going to play for the 2D cases. So these rest of the four options will be falls under the 2D. So that I'll be discussing in the next session. Okay.